Okay, so welcome everyone to the third ever Amos product call. We have gathered here to categorize and tag and structure and organize the world's knowledge as represented by all the online learning resources that are on the World Wide Web. So let me first give you a few sentences about Amos. Amos is our attempt to do exactly what I just stated. Why are we doing that? The reason is because once we categorize and structure online learning resources, we'll be able to create a search engine across those resources that will be much more semantic than the existing solution, which is something like Google. So while Google uses a lot of machine learning for them to show you the best results, we think that until we have general intelligence, general artificial intelligence, which is even questionable whether that will be in our lifetimes, then a machine learning approach will never be able to provide the same level of semantic granularity as human submissions. So essentially, Amos can be categorized into two phases. The first one is where we build out a platform that allows the wider community, in fact, anyone, the whole world, to contribute in categorizing learning resources, in particular information about them, which we call metadata, which I'll get to in a second. And then second of all, there'll be a phase where we'll introduce search across all of the information that we have. And that will allow you to search for anything that you want to learn. And it can be parameterized by what you already know, the ways you prefer to learn, and also how much time you want to spend on it. So that was a 2-minute summary about our product, Amos. And what we're going to discuss in this call, is predominantly the pretty much final specification of the first development effort. So in this call, we don't assume you've attended the previous two calls, because we're going to wrap everything up from the very beginning and lay out sort of the specification for the very first version of Amos. So let's get to it. So I'm going to start by explaining the concept of the knowledge tree. Now, the knowledge tree defines topic hierarchies. Now, just a quick thought. So there is oftentimes, when you're creating these information systems or databases such as this one, a trade-off between how much semantic you want it to be and how simple you want it to be. So you want there to be as small a line as possible between a real world human semantic level of understanding and the computer semantic level of understanding. But at the same time, that often creates like complexity. So then there's another axis which you want to also optimize for, which is simplicity. So if I'll give you a very, very simple example, if we were able to categorize, or if we were going to categorize our learning resources by just one simple category, like math, history, computer science, law, then that would be very, very simple. But the difference between a human semantic understanding of this topic and the computer would be very, very wide. The computer would only know whether the learning resource is historical one or mathematical one or a law one, but the human knows much, much more. So that's kind of what I wanted to just touch upon to find this balance. So definitely wanted to be much more semantic than just simple categorization, which is very often also something that existing solutions use, like Coursera or Udemy. But at the same time, we want it to be doable, to be able to develop it, test it, secure it, and most importantly, maintain it. So with that, let's discuss the specification. So the knowledge tree is essentially a tree, but we also allow linking of topics horizontally. So for example, I can show you maybe a visualization. So if we have this is just a very rough draft that I've worked on yesterday. So, oh, by the way, the format we're using is these don't increment at the same level. They actually increment at differing levels, and that is for to make it easier to see with your eyes. So it's slightly different format than you might be used to from regular language. So we have something that resembles a tree, but then we might allow linking of topics. So let's give an example. Economics might include the field political economy. But political science might also include the field political economy. So since we want those to be equal, we're gonna create a link here, which we can, for example, denote with the symbol #1. So let's go back to the structure or schedule. And so the reason I decided this is, as I and we really started to create these knowledge trees, we realized that there are a lot of subjects that are interdisciplinary, and especially in the humanities, but also in the sciences. So I'm gonna give you a few that I listed out here. Political economy, that we already discussed. It concerns itself with what is the right political policy approach, given what maximizes the wealth of nations, to put it in the phrase that the famous economists in Scotland put it in the 18th century. But there are a lot of other such topics that are very interdisciplinary. One that we're working on here at Salvia Foundation with a product called Pruvio is actually a topic called computer algebra, which is an interdisciplinary approach between mathematics, namely algebra, and its computer implementation. Other example could include computational physics or mathematical physics. They're two very different things, but they both fall under this category. And even in the social sciences, the economics of law, and many others. I have a list here on paper that is much longer than this one. An interesting example is the topic of formal languages, because this is actually under 3 topics. It's under linguistics, it's under math, and it's under computer science. So you can have a topic that is, all 3 fields consider it their own. So that's why we allow this linking of topics horizontally. And another cool thing is that it also allows different ways of categorization. So I'll give you an example in history and maybe even in law. So in history, you might have, you might want to categorize it in the tree by time. So you might want to say prehistory, pre-ancient, ancient, medieval, modern, contemporary, present. But you might also want to categorize it, by location. Africa, South America, North America, Europe, Middle East, Russia, India, whatever. And so this allows you to do both. So history will have all of these nodes, and then there will be a node which says, medieval European history, and that will be linked to both the European first class node and the medieval first class node. So another advantage of this linking is that it actually allows you to categorize topics in different ways. Now, I'm not an expert in law. In fact, I'm not even a novice, but I believe in law there is something called common law and civil law. And let's assume for the sake of argument that both of these fields have a bunch of subfields such as corporate law, family law, property law, etc. Then again, you might want to categorize law by either common or civil, which are the legal systems used in various countries. But you might also want to categorize it by the field of law that you're actually examining. So again, what you can do now is you can have first-class nodes be both common and civil and all the fields. And then you can create subnode such as common property law that will be linked between both common law and property law. So that's pretty cool. Now, this is kind of what I'm getting to when I talked about the trade-off between semantics and simplicity. So we're not going to allow linking percentage-wise. So you can't say this topic is 80% computer science and 20% math. You can only link once or not at all. So essentially that means that these interdisciplinary topics that we're talking about, they will either be 100% under one field and 0% under the other. That's the case when we don't link it. Or they will be 50% under both, in which case we link it. I think that's a really, really good trade-off between the level of semantics as well as simplicity. And then I wanted to comment that, yes, the prudent listener will realize that it is actually not a tree, but we can think of it more like a DAG than a tree. But nevertheless, we call it the knowledge tree. Now, the last thing I'll say about the knowledge tree is that it's fixed, pretty much fixed. On the UI, you can't change it. The reason is we wanted to change as little as possible. So it's our responsibility, the Solvio Foundation, to come up with kind of an initial knowledge tree, which is what I'll be working on in the next week or so. And then we put it on GitHub, and we allow changes through pull requests. So I think that at the beginning is the best way to do this, and then the backend can always see what the latest sort of knowledge tree on the master branches, and can use that for its data model. Cool. Now, why are we constructing a knowledge tree? We're constructing a knowledge tree because essentially we want to link resources with topics. So that brings me to the second most important data structure, the resource tree. Now, I talked a little bit about the resource tree in the very first call. So let me just quickly recap. Actually, maybe first I wanted to say about the knowledge tree. So in the knowledge tree, the nodes are called topics, and the leaves are ones that are non-divisible. And only leaves really have a level of depth. Level 1 is if you can learn it in 15 to 30 minutes. So usually that's statement of the theorem and maybe a proof or an example. Level 2 requires another 1 or 1.5 hours. And level 3 requires another, let's say, 5 hours. There's no level 4 because topics that require more than, let's say 7 hours to learn, they should actually be split up into their respective children. And then the depths of non-leaf nodes are calculated recursively simply by addition. So in other words, we could say levels bubble up. So if I have a level 10 in number theory, you could ask, how is level 10 possible? Well, the reason is it's not a leaf. Number theory has a lot of theorems in it, and maybe I have level 1 or 2 in a few of them. So then overall, I'm level 10 in number theory. And let's say I'm also level 10 in geometry. Well, maybe that means I'm level 20 in mathematics. So levels bubble up. Now, that's essentially what I wanted to say about the knowledge tree. Now let's go to the resource tree. So the resource tree is essentially separated by the author. Those are like the first class nodes. So you could have a first class node be the University of Oxford. You could have under that the Oxford Maths Institute. Under that you could have the lecture notes of the lectures. Then you could have the school year 18 to 19, the term, the trimester, and finally the course itself, analysis 1. And either the user ends there, or if the user is a quality submitter and or wants a lot of reputation, then the user would also split up that resource into, let's say, the individual chapters. So we want to go very, very granular with the resource tree, because that will mean that will allow, we won't just be showing whole courses, but we could be showing, parts of courses. Obviously, there's a level to this. You don't want to be, categorizing every single sentence. But for example, if there's a book or a very long course or whatever, then it does make a lot of sense to me to make each chapter a separate thing. Sometimes it's just one chapter in a book, let's say 1/4 or 1/10 of the book, that you might recommend to somebody for various reasons, because that's exactly what they're looking for. The resource tree is okay, let me say this first. So each node in the resource tree has something we call metadata. Now the metadata we'll be starting with are going to be the type, which is essentially will be explanation for most of our first resources, but it could also be other things, exercises, maybe possibly to ask questions, communities, an FAQ, whatever. The second field that we're going to be starting with is access. So by access, we mean essentially a triplet. Here, I have this somewhere. Here, perfect. Essentially a triplet. What format it's in, how do you acquire it, and possibly, which hopefully will be empty most of the time, an array in the country restrictions, which countries cannot access it. Now, there's maybe a little bit more semanticism we could go through, but I think this is pretty good. So the format can be video, audio, or text. How do you acquire it? Can be free, can be paid, or through subscriptions such as Netflix or Audible or Blinkist. And of course, the country restrictions. Now, the access field, it's not an object, it's an array. And the reason is there could be multiple ways to access something. Yeah, And each of these triplets has like a direct source, which could be again a lot of links because there could be multiple links to the same access, and also possibly a download source. Now this can be a little bit more semantic, like if it's an application and you can provide a link to the actual location in the app, then you could also say something like in app, and you could provide a description of how to get there. For example, hit search and type in ancient Rome. And then another cool thing is like two things that come to my mind, which I'll say real quick. First one is like I was thinking about maybe good categorization would be like instead of by author, so like University of Oxford, a better categorization would be like by platform, so like YouTube, Coursera, blah blah, Blinkist. But then I realized actually that's not good because we have that information in Access. So if the link is on the domain youtube.com, we already know it's from that platform. If it's Coursera.org, we know it's from that platform. So then you could also obviously filter by the platform. You could say that you prefer YouTube, or for example, if somebody enters video and puts a YouTube link, then we might say automatically we know it's free, and automatically we also know that there is text that can be at least computer generated, etc. And I think there was one more thing I wanted to say, but yeah, then there's something like, for example, summaries. So I was thinking whether like there's this platform called Blinkist, which do like a lot of book summaries. So I was thinking whether that should be like inside the resource itself, but it doesn't matter. It's a little bit complicated. We can get to it when the topic arises. Okay. Is there anything else I wanted to mention? I think that's it for now. Right. The next field that we'll be starting with, we call topics. And so topics is, again, it's sort of an array. And usually it's like one topic, but in theory, it could also be a resource. So for example, summaries, reviews, literature criticism, the topic itself will be a different resource. So this is what I was getting to with the Blinkist, is that we won't be, for book summaries, we won't be putting them under the author itself, because I think it doesn't make sense to say that he wrote the summary. Instead, we'll be putting it under Blinkist as the author. But the topic will be a reference to the actual resource, the actual book. And I also remembered what I wanted to say before, and that was that, so yes, each node has these metadata, not only leaves, but it like bubbles up also. So for example, the type, if the leaves have type explanation or exercise, then the parents will have just like, the union of all the listed types. And same with topics, and same with dependencies. So we're talking about dependencies, so let's talk about that. Dependencies have 5 strengths: required, strongly recommended, recommended, it will be cool if you know it, and it will be good if you know it. So that's the strength, either 0, 1, 2, 3, 4, 5. Then the dependency is always to a topic. So, initially when people start hydrating our database, they look at a resource from, let's say, Oxford, and they see that the requirements are a discrete maths course from Oxford. So that's not what we're doing. We're not saying that the dependencies are other resources, especially from that author. We want to convert those resources into the topics that they're on, so that we essentially don't end up with like these centralized learning paths, like Oxford, and then all the courses from Oxford, Cambridge, all the courses from Cambridge. We want it to be really, really plug and play. So what we do in that case is we look at what the Oxford course discrete maths goes through, and then we list those topics as the dependency instead of the resource or course itself. Now, initially the idea was also to add like a level, but then when we started hydrating the database, we started iterating over this, we actually realized that oftentimes these courses, they say like you have to know number theory up to something. So I think we should also allow that. We should allow either you can enter a level or you can enter up to some theorem. And ideally that will just be on the UX side, and it will immediately convert it to a level depending on that particular topic. What is the level you need to get to in order to understand that theorem? And I think in one of the previous calls, we wanted to do this thing which we called unit extrapolation, which was essentially if I say that it is strongly recommended that you understand something at level 1, then we sort of extrapolate on a unit scale. So then we say it is recommended that you understand it at level 2. It would be cool if you understood it at level 3, and it would be good if you understood it at level 4. But I think that doesn't, in my view, add a lot of value, and in fact, it's better to keep it more granular. That there could be individual discussions, which we'll get to in a second. The Amos game, there'll be individual games on each of the strengths. Cool. So here, let me just take a 1 minute break. I'll also, actually, yeah, do you want to take a short 5-minute break, and I'll also pause the recording? Okay, we're back. So let's continue exactly where we left off. With the metadata, this is important. Once a node has children, you can no longer add type, topics, or dependencies to it without adding it to one of the children. So essentially, at first, we allow adding things like analysis lecture notes for the analysis course in math. But once the course has been split up to its individual chapters, then you cannot edit that course directly. I think the only one that's missing here is access, so you might be able to edit that. But most of the metadata has to go through now each of the children. So this essentially creates, a partial order where the database will be getting more and more granular and not less granular over time. And let's see. Oh, and also I have that you cannot no longer vote on any of the things from the parent. Now you have to go and vote for the children. So having discussed the metadata like this, let's go back to where we left off, and that was over here. So the resource tree is not as fixed as the knowledge tree. it's not stored on GitHub like the knowledge tree is. It's stored in, well, a database. And as such, we must allow ways to edit that database through the application. And that's what we're going to talk about in a second in a chapter called Operations. Before we get to that, I want to mention two things. Number one, initially the idea was for the MVP to have sort of a static scalar field called reputation. I believe it would be really, really nice to actually have a reputation tree. So let's say you submit some information about the individual chapters of the analysis course. Then you will get a lot of reputation in whatever the individual chapters discuss. And just as levels bubble up, reputation also bubbles up. So if you have 5 reputation points for, what is analysis about? Some topic in analysis, then you will also have 5 reputation points for analysis and 5 reputation points for math and 5 reputation points overall. So it will essentially bubble up. Now, Ani, if you are available now, I actually have a question. Do you think that a reputation tree is doable on the backend technical side, as in have for each user an actual tree for his reputation? Do you think that will be doable, or do you think that will be too technically costly?
So when you say reputation tree, it means like for a particular user at one given point of time, there will be only one reputation, right?
No. So for the knowledge tree, for each user, they will essentially have their own knowledge tree with reputation for each of the nodes.
Yeah. So for every type of one particular type of resource, there will be one reputation.
One particular type of topic, there will be one reputation, like one node in the topic tree.
Exactly. Yeah. So yeah, then it can be definitely be done.
Awesome. Sweet. That's really good to hear. So that's what I wanted to talk about, number one. Number two, the Amos game. So we already talked about this in the last call, but in this one, we're not assuming that you've seen it. So let me just recap in one sentence. Some information systems, such as blockchain systems, they need what's called an oracle. An oracle is a way to get data from the real world to the information system. And very often what's used for an oracle is something called a decentralized oracle. A decentralized oracle is essentially where the central authority does not dictate the real world data, but rather it arises from some spontaneous order or spontaneous behavior of self-interested agents in the network. Now, we're not building a blockchain, but we're building a database, and it makes a lot of sense to make that database as permissionless and controlless as possible. And so in this proposal, we propose to also use a decentralized oracle for the gaining of our metadata. Now, the most common used decentralized oracle in blockchains, and the ones we're going with, is called a shelling game. A shelling game is essentially where you ask the self-interested participants a multiple choice question, such as who won the World Cup, and let's say it was Spain, and they are all incentivized to pick the answer that everyone else chooses. And since we're assuming that Spain won the World Cup, that will form what's called, in game theory, a shelling point or a focal point, and they will all congregate on that point. They will all gain some some payoff and some reputation, and the ones that picked a different option than Spain will lose reputation. So they're all incentivized to pick the same option, and if there's belief that the correct option will be chosen, then they're all incentivized to pick the most accurate option. Now, we're using something we call an Amos game, and we're splitting it up into two: a limited Amos game and an unlimited Amos game. Now, we talked about this a little bit in the last call. The changes since then have been that now also subtraction is possible. So if you have sort of a field with an actual order, what's a field with an order? Well, an example would be the quality or the dependency strength, I guess. Or actually not the dependency strength, but let's say quality, even though that's not in our initial metadata model. Then if let's say quality is from 0 to 5, and let's say that if you pick the right option, you will be getting +2 reputation points for every other person that has voted on that option. And if there is a delta of 1, for example, you pick quality 4, but another person picks quality 3, then you will be getting 1 reputation point. However, if the difference is very large, then you will actually be subtracting reputation points. Now, the exact constants for this are up to discussion. They are not, they're not necessarily that important. In the last call, I proposed something very simple, which is 1 reputation point after you get, let's say +1 rep. If 10 reputation points votes on the same option, you get +2, 100, +3, and it grows in a logarithmic fashion. But as I said, the constants are not that important for the specification. One thing I thought about is whether we should allow changing votes. And it seems to me that the best option is yes. And then it begs another question, which is what happens to your reputation? So if, okay, so I'll give you a simple example. I voted on quality 2. I got some reputation from that. Now I want to change to quality 3. Should my reputation that I gained from 2 be subtracted or not? And yeah, this is actually one thing that I am not 100% sure about, but I feel like actually, like on the game theoretical level, it doesn't matter, because if you think that quality 3 will be better long-term than quality 2, then the current, any current state will not change that. If you think that asymptotically or like in the long run, quality 3 will be better than quality 2, then both, if it gets subtracted and if it doesn't, it will lead to the same dominant decision, to use game theoretical terminology, which is to change your vote. So actually, in some ways, this doesn't matter. I also thought about whether you should be allowed to vote on a 0, such as saying this dependency is not there, this topic is not there, and again, it seems to me that should be possible. I also thought about whether we should have some equivalence relations between dependency strengths. So let me give you an example. You have these 5 strengths, and let's say that there is some guy who says that at a strength of 4, you should know some topic, let's call it number theory, at a level of 5. And then another guy says that at a lower strength, you should know the same topic at a level of 6. Then, in some ways, these could be seen as equivalent. But I think it's much easier at the beginning not to form equivalence relations between dependencies of different strengths. So in other words, every pair of strength and topic will be its own Schelling game, depending on the level. Since we're also removing unit extrapolation. That's actually the same thing. Removing unit extrapolation and not having these equivalence relations is pretty much equivalent. Obviously, if somebody says something that is smaller than 5, such as 2, then in some ways it's contradictory, but that would just be handled on the side of the Schelling game. So, yeah, that's what I wanted to discuss. We also have a concept of an unlimited Amos game, which, I actually already talked about. In fact, everything that I talked about here was regarding the unlimited Amos game. And I have one more point here which we can discuss, which is, a few calls ago, we had this open question of whether to create like this single source of truth, append-only database, or whether to have this like weighted average thing. And I feel like for the data model that we've chosen with this like Schelling game concept, it makes sense to do the weighted average thing. That can be initially weighted by just mere reputation, and again, the constants can be fiddled around with later on. So maybe an example would be handy. Let's say I have quality, because we're talking about it all the time, 2, and there's 500 rep on this option, and quality 3, and there's 800 rep on this option. Then the algorithm, let's make it maybe a little bit nicer. Then the algorithm might compute that the quality that the database sees for the purposes of search later on is 2.666. Yeah, so again, the different constants can be finalized later. For now, we can just take a simple average weighted by reputation. Cool. So let's now discuss the limited Amos game. The limited Amos game is essentially a Schelling game. How long will it last? It will last depending on the importance. So if you're changing something very simple, it might be a 1-day Schelling game. If you're changing something very important, it might be 2 weeks. And so how it will work at the end of the 2 weeks, whoever pointed out to the most popular option, again weighted by reputation, will get some payoff, and those who didn't will lose something. Now, those were the 2 things I wanted to discuss before we get into how do you change the resource tree. So I call that chapter operations. Now, I separated the operations by which Oracle we're using. For the unlimited Amos game, that's for editing, or essentially what this means is, contributing and voting on metadata, and but now let's discuss the limited Amos game. So as I thought more and more about the resource tree, I realized we need actually quite a lot of work and effort into maintaining it. So this sort of administrative jobs that make sure the resource tree is coherent and consistent. The operations that I thought of are the following. Merge two nodes. So there's two nodes that are actually the same topic. We want the option to merge them. This begs another question, merging, which is how do you merge the different metadata? And for that, it's actually not that hard because you can just take the union of all of the metadata, both the type, the access, the topics, and the dependencies. You just take the union, so it actually turns out very simple. Another operation would be to link nodes in a parent and child relationship. So let's say there's a node on analysis 1, and then there's another node on one of its chapters. Well, we want to have a UI supported operation to link these two nodes in a parent-child relationship. Next, to create a parent. Let's say there's analysis 1, chapter 1, but analysis 1 is missing. So we need to be able to create a parent. Similarly, vice versa, we need to be able to create a child. Let's say there is Oxford Maths Institute and there's immediately chapter 1 of analysis. Well, we have to be able to create a connecting node. This is essentially a higher level operation because you can always think of it as either creating a parent or child and then linking the opposite. But I here set it as its own separate operation. Also the possibility to unlink two things if they're mistakenly linked. And finally, the option to delete a node if it doesn't represent a learning resource. Now, I thought of the best way to handle this on the UI. And I thought of various ways, but it seems to me the best is through a chatbot. Since these operations are not that easy to display in another way on the front end, it seems to me the chatbot option is the best. What are the other ways I thought of? I thought of a search bar where you could search for the different resources, you could select them, and you could hit edit, and it would essentially bring up almost like a text editor where you could see the two trees, which would be just in a very simple text-based format like this, and then you could do your edits, and then you could hit submit, and that would create the limited Amos game. But I feel like a much easier side, both to develop and also for the user, would be if an actual character guides you through the operation. So you hit something like edit resource tree, and Amos will chatbot with Amos will pop up, and it will ask you, okay, so what do you want to do? And it will guide you through the edit, and then you will click submit, and that will create the limited Amos game. Cool. So the only thing that makes sense to me not to allow is to split up a node. Instead, a child should be created with its own sort of separate metadata that would be blank, and then of course you can submit to it, and of course also, as I already mentioned, you no longer can submit to the parent. And also, I don't think it should be possible to split up sort of bulk dependencies. So if there's a dependency to number theory at level 15, I don't think it should be allowed to split that up into the theorems of number theory. Instead, what you should do is create the array of dependencies of the theorems that are more granular than number theory. And I guess both will continue to exist, and we'll see both. And I think that if there is an inconsistency between the theorems and between number theory as a higher level topic, then that would be a good indication that our database is, or at least the Schelling game product of it, is a little bit inconsistent. This will also be a very, very good feedback as to the consistency of our data. Cool. Before I talk about UX, maybe let me just say one more thing. So as you can see, this stuff has turned out to be a little bit more complex than we initially thought, but that's not really a surprise. Like, when was the first time we wanted to create an app that would have such amazing functionality, like to search any learning resources and get personalized and parameterized results, and it being easier than you thought. So while I was thinking about this back in the last few weeks, it made a parallel popped up in my mind to what I used to do in my last company called formula verification, where you want to formally verify stuff and you're like ready to start learning, but then you realize actually first you have to learn about semantics, semantics of programming languages, semantics of the programming language of virtual machine that you are working with. So that's like 80% of the effort is just the semantics. Once you have that, then only 20% is to learn about how to write the specification for the program, and then obviously the proving, the formal proof part itself is handled by the proof engine. But it's like 80% you actually have to learn just the spec, which at first, the semantics, which at first you think is something completely unrelated, and most importantly think you won't even need it. So here it's exactly the same. I think that 80% of our work will be sort of specifying the knowledge tree, specifying the resource tree, and most importantly, filling it up with content, the resources, and the metadata. And once we have that, search will be 20% of the effort. Cool. So let's talk about UX for a bit. So there might be some UX backend interop where we essentially help or guide the user. So one of them I already mentioned. If you enter dependency up to a certain theorem, then it might calculate immediately the level. Another example might be, okay, I can think of two examples. So the first one is, we mentioned we allow linking of topics horizontally, but there might be topics that we don't want them to be exactly the same, but they're like similar. And there also we could use suggestions. We could link them like on the UX level. So like if you say this is of this topic, maybe it's also usually another topic. And the second thing I can think of is dependencies. So we might have like we already mentioned this in the previous calls, concept of natural dependencies. And if you enter something as a topic, then we say that like most of the time this topic requires a different topic, so it will like immediately suggest it to you. And the natural dependencies can be sort of centralized, pre-filled at first by us, and then in the future can use the dependency values themselves. So for example, something like formularification usually requires semantics of the programming language. Something like computational physics or optimization usually requires some math. So these would be natural dependencies. Now let's talk about the actual user flows. So you will be able to change the topic tree only through GitHub. You will be able to change the resource tree through, of course, either voting or adding metadata. Actually, that's a separate point. But most importantly, through the non-trivial operations, the maintenance moderator level operations, they can be proposed by anyone, but it's very likely that only experienced users will be able to have a lot of say, because it's all weighted by reputation. And those are done through a chatbot, and the voting or the submissions are done through the app or the Chrome extension. And yeah, that's also this point as well. You should also be able to vote on the limited Amos games that are happening. In particular, just a reminder, in our case, the only limited Amos games are the heavyweight maintenance of the resource tree. So you should be able to see the ones that have just begun or the ones that are just ending and vote on them. And oh, sorry, I have someone's at my door. Let me pause the recording. I'm not expecting anyone, so it's probably a mistake. Okay, we're back. So another thing we were talking about was whether you should be able to see the metadata for the individual resources. Actually, that again, it's pretty much an open question, or like, it doesn't really matter. I would be fine with both. So this yet to be decided. Like, what I'm trying to say is there is some value, in my opinion, to keeping them secret, so to speak, on the incentive side, because if you can't see what other people are voting for, then maybe it makes your answer more correct on average. But I think we should side with being able to see the metadata. So for any resource you click, you can see exactly what's happening. And finally, here I have two more ideas that I want to talk about. So let me write that down before I forget. Yeah, I already forgot the other one. Okay. Oh yeah, and whether you should be able to see the excuse me, your own profile, whether that's a user flow wanna enable in the very MVP. Again, I am kind of undecided. Yeah, depends what we decide. Both is fine. And finally, I wanted to talk about some rules that we have for our community. The first one is that you should not encourage others to merely vote on your votes for the sake of gaining reputation. First of all, it will be bad for them, because people should be incentivized, well, they are incentivized to vote for the option that will gain the most popularity in the future, and hence they're incentivized to vote for the most accurate option. So voting just because somebody else voted can be, you know, in a way dangerous, can even lead to subtractions of reputation. And most importantly, it's also bad for you because it will lead to you being banned. And similarly, you are not allowed to do reckless voting, which is defined as voting on resources without having read the resource and thought about how to categorize it in that particular field. And if we observe that, again, it will lead to being banned from the platform. So I've also, maybe I'll catch up with you as in what other stuff I've been doing this week. So I've actually started 2 books, not 1, but 2, on building communities. They're very, very good. Both of them are absolutely terrific. And one thing that came out of them is we really want to sort of, like create leaders in our communities, like give responsibilities. So one of the consequences of how that materialized was this idea of having the reputation tree, because that really like provides a granular like differentiation between the experts, or moderators in a quote unquote, in the different topics. And one other thing that we could possibly do is have some more human readable levels once you achieve a certain reputation in some field. There was an example of one company, I think Kaggle, I think they do data science, that used a scale of novice, apprentice, intermediate, expert, and grandmaster. And this could either be only for the first class nodes, such as math and history, or they could be for all nodes, whatever. But what's also cool is that, like, if we define grandmaster as like 0.4% of all people in that field, then that will incentivize you to keep on growing reputation, because as your share of all reputation lowers, there's a chance you will lose that badge. And also what I really like about the model we came up with is you're essentially gaining a reputation all the time for your previous contributions. So there's like this aspect, like a few years ago, I read this cool thing called Hooked. And it's about like what really like hooks people into an application, what keeps them coming back. And it's, things like replies, comments, likes, reactions from the community. And yeah, since your reputation is always increasing, there is some level also, there's some hook that you want to check if somebody has agreed with you. And finally, I propose we use discourse for the discussion of these things. Now I'm thinking, because I was also thinking that you should be able to attach a comment for your contributions. So this is like one of 2 things we could do. Either sort of do a discourse and have no comments in our thing, or do both. You can only attach like comments to like edits, but then other discussion is done on discourse. Or possibly we could like sort of integrate the whole thing. I don't know if that's possible, but since discourse is open source, then in theory it's possible. I just don't know how much work it would be. As in, you could sign into the Amos. This would be a new discourse than the Solvia one, and you could sign in there with your Amos account, and then maybe every time you comment on something, it would automatically start a thread or topic, as it's called in discourse, and then other people could comment on that. Or for example, if you're putting it to a resource, then there would be one thread for each resource. That would be pretty cool. If we so you could, in other words, you could submit it through our app to comment, but then there would be like no forum in our app to keep development simple. That would be done on the discourse level. And then the very last thing that I have here. Sorry about the call being so long, but I think that there's a lot of like finalization now, and I think we're pretty much 70% of the way to like the specs. 100% specification would mean recreating the whole code. So spec is never, in my experience at least, like fully encompassing. But I think the individual sort of edge cases we can sort out as they come up as we're developing. And the very last thing that I wanted to mention was in the last call, I kind of we ended it, and I didn't have such a good feeling because I felt like the security part was not answered. But I've thought about it a little bit since then, and I'm much more optimistic now. So a few things. Number one is I guess we're not designing a blockchain where that has monetary value. Like, let's compare our system to Ethereum. If you do a DOS attack on Ethereum, which happened like in 2016, then not only does it block the entire Ethereum network, there is also monetary loss, and most importantly, it's really, really hard to correct it. Why? Because Ethereum is a nobody controls it, right? So there has to be a hard fork, etc., which there was. If you try to sort of spam or scam our system by creating a bunch of accounts and giving them reputation and then taking over the whole thing, first of all, you're just you're not scamming the entire system defaultly. You're just having the changes to the resources that you decide to do. Second of all, there's no monetary gain or loss for any side, and in particular, we're a nonprofit institution, and at the moment we don't even have a competitor. There's no one doing the same thing as us. So there is less incentive on the financial side. But most importantly, one advantage of not having blockchain is we're still in control. So if somebody does all this stuff, then very easily we can always correct it. And that leads me to the second thing, which is, right after the call, I had a very simple idea, which is it's actually very, very easy to prevent Sybil attacks. So just a quick recap from the last call. We ended the game theoretical model with like a few challenges, but we essentially solved the first and third already in the call, and the only one that remained was like Sybil attacks. How do you prevent from people creating a bunch of accounts? And there's actually a very, very easy solution for that, which is either force people to sign up either through Google or Facebook, or even if you do allow email signups and you have some super open API that allows people to sign up like without having an API key, and we are even and they're so smart that they go through Tor and we can't even see that one IP address created a bunch of accounts within 1 minute, then even then the solution is very simple. Just require a mobile phone number, right? So actually it turns out Sybil attacks are very, very easy to correct. So if we do get attacked in this way, we delete the fake accounts, we set up a mobile phone a requirement in order to register a user, and we keep going. And I think there's like two extremes, right? There's the extreme of Ethereum, which just got DOS, in which like if you DOS Ethereum, you're spending money because you have to be paying gas, and you're by definition not making any money. So it's literally like spending money to attack the network. So that's like pure evil. It's probably like the worst sort of attack that somebody can do. Whereas on the other side, there's something like Wikipedia that most articles are fully open to be edited. You can edit it, with just an IP edit, and it kind of works. So in other words, there's some scale between being secure and being paranoid. And I think last time I went a little bit to the paranoid level, um, and I think that since we have like a solution in case it does happen, which is we're always in control and we can always set up a mobile phone requirement, which turns out it's not easy to get a throwaway number, we're good. Anyways, lots of good discussion today. I'd like to hear your ideas. My impression is that this is doable. So I'd like to hear your ideas on number one, the specs, and number two, Ani, I'd like to hear your thought on one specific question, which is, should we use Reason ML? Because it's just an absolutely fantastic language for traversing trees, etc., and functional and 100% type safe and immutable. Can this stuff be handled on the side of Cypher, which is the query language for Neo4j? What I'm trying to say is, I was thinking about how we would write this in Reason ML, and like you still don't have access to the database in Reason ML, even if we assume we're doing we're compiling it to JavaScript, or we're translating it to JavaScript, and we're just using those functions, JavaScript functions. Still, you would have to, in my mind, pass in like the database as a parameter to the JavaScript function in order for it to be able to spit out the data, which obviously doesn't work. And then the second question, which I have for Evgeny, is what do you think is the best front-end framework to do this stuff? So I don't know if you guys heard, Chrome recently came out with this beautiful thing. Google has been talking about it for ages now, but now they finally implemented it, where you can make an app and you can just hit 3 buttons here, and you can hit this button called install Squoosh. I've already installed it, so now it changes to open in Squoosh. And if you click that, you will get a fully fledged application running on your desktop. You can close that application. You can open it again through Alfred, and you have like a fully fledged application from the user side running actually inside the browser. So I think that's pretty freaking cool. So my question is, I leave this to you obviously as sort of the head of front end right now. Should we make a mobile app as well? I mean, React Native Web, or should we just go with React? I think that it would be really, really cool to make both a web app and a mobile app, because it shows people that we're really serious about this idea. Yeah, that's up to you to decide, essentially.
For one, I think we can go with Reason ML, and we can have our own parser which can pass on the data in Cypher format or other formats to Neo4j if we are using Neo4j. If not, we can also use other graph databases like OrientDB and so on. But even if we are using Neo4j, we can have the parser which can rewrite the things. Reason ML, I mean, you've already written a bunch of that code, so it gets easier from there, from the functional point of view.
Got it. What do you mean by parser? So you're gonna be spitting out cipher code from ReasonML, or
If in case it's needed at all. But otherwise, I think ReasonML converts everything to JavaScript anyway. So I don't think we might need that.
right.
But if in case we need, then we can write a small parser in between.
Got it.
Like I think Neo4j also has some ORM level stuff. So I think we can use some of those libraries directly.
Perfect. Evgeny, what do you think about the front end side?
Of course, if we need the same functionality in desktop web and in mobile applications, the React Native web could be an interesting solution.
Perfect. And then there's also another thing. Yeah, like essentially, you know much more about this stuff than me. And also, it's better if you make that decision. But maybe I'll give you another thing to think about. Ideally we would want a mobile app, a web app, and then also the Chrome extension.
Yes.
So maybe you can start thinking about how to have the UI be as similar across those three products, so that we can reuse the code. And yeah, the user flows are all over here, and I will also share the link so that you can always find the user flows and you can start thinking about it.
But usually the desktop application looks more complex than mobile apps.
Right.
And I suppose if we would go that way and use React Native Web, I think that the desktop app won't benefit from this.
Right. Yeah, that was also like my impression. What I wanted to do, I didn't have time to do it before this call, was actually look up an actual example if they have, where we could see how we could actually see how like somebody implemented it and how it looks maybe on mobile even, and most importantly, how it looks on web. Let's see if there's okay, so they do have an example.
They would usually have a different design altogether.
Right. I mean, I totally get that, what you guys are saying. But it just seems to me like it would be cool to also have a mobile app.
So maybe you can start with a responsive web app, and then probably down the line.
I guess to sort of summarize the discussion, it's either to have a mobile app and kind of a less functional desktop app. So either to sacrifice the desktop or web app, or to have a fully fledged web app and to sacrifice the mobile side. But I feel like since we want a responsive web app anyways, then that's essentially, what I'm saying, that's essentially equivalent to a mobile app as well. What do you think? Yeah, we'll think about this. Also, I'll look up some examples, and like one thing that I'm interested in is if we have these tabs on mobile, then how does that translate? Wait, where are they? Here. If we have these tabs on mobile, how does that actually translate on desktop? Like, do they show up as like 1, 2, 3, 4? And like, I would want to try that to see if it's actually good UX, or maybe read something about it. Because I think I saw that once in an app, and it was actually, I thought it was good. I felt like the web app, it felt like a mobile app. And for some reason, it felt good, even though like it, you might think it's unprofessional. Or, ideally, if the tabs maybe get translated on web as like, on the top or like a sidebar, I would have to see what other people are saying about this. And also, I will talk with Ash, our volunteer designer. He's coming back to Czech Republic today. So we'll probably meet up either tomorrow or on the weekend. And ideally together, we can design the mock-ups. Okay, guys, I'm really happy to have 70% of the specification finished. And let's take a few days to prepare. And I think that on Monday, we can start implementing.
Okay.
Are you guys going to join the regular call?
Join?
On Sunday?
Yeah.
Yeah, sure.
Awesome. Yeah, no, I just wanted to say I really appreciate like everyone's like contributions. And while it might seem a little bit complex now, I feel like the fact that it's complex is almost a good sign. So there's this like interesting balance among startups that I've observed, which is you want your tech to be as simple as possible, but at the same time, if you're doing something hard, it's usually a good sign. But at the same time, you want it to be as simple as possible. So I think we fit both of those rules. And usually doing non-trivial stuff also means that, you know, there's some barrier to entry. So it means that it increases the likelihood that nobody came up with it in the past, even though it was a good idea. And also, you know, we're not really concerned with that, but if we were for profit, it would also increase the barrier for anyone to compete with us. And as I said at the very beginning, there's like some trade-off between semantic level of depth and simplicity. And I think we've hit a really good sweet spot where we're a little bit more complex than sort of the trivial categorization, you know, math, history, psychology, law. But at the same time, we have a data layer that is doable and that scales because it doesn't require us to set admins and mods, but it should, the community should be self-correcting. So I'm really, really excited about the future.
Cool.
Yeah. So thanks guys for watching this video. And if you want to stay in touch and join the community, then head over to solvio.discourse.group. You can also see it on my screen right now, and post something about yourself.